All right, let's talk about something that's all around us, but completely invisible. Every single antenna, the one on your phone, your Wi-Fi router, even those giant broadcast towers, is surrounded by these invisible worlds of energy. And what's wild is that these worlds, which we call the near field and the far field, behave in completely different ways, even though they're literally right next to each other. Now, for those of you who've been following along, you'll know this is part 10 of our deep dive into radio frequency propagation, all based on a report by the RFI detectives. And hey, if you're just jumping in, no worries at all. This explainer totally stands on its own. So let's start with something you've probably experienced yourself. You know when you get your hand really close to an old school radio antenna and the signal goes all staticky and weird, but you could be doing jumping jacks on the other side of the room and nothing happens? What is going on there? Well, the answer is hidden in those two invisible worlds. I want you to imagine that the space around an antenna isn't just empty air. Instead, it's filled with these invisible energy zones, kind of like bubbles. And the really crucial thing to get is that the energy in each of these bubbles plays by a totally different set of rules. So, to make sense of this, scientists basically draw a line in the sand. Right up close to the antenna, you have what's called the near field. And then, stretching way, way out, you have the far field. Now, there's a little transition zone in between, but for today, let's just focus on these two big ones, because that's where the magic happens. Let's zoom in on that first bubble, the one that's practically hugging the antenna. This is the near field, and you can think of it as a place of, well, controlled chaos. It's the antenna's private workshop. So what does that actually mean? Well, in the near field, the antenna is still getting the signal ready. The energy here isn't really going anywhere yet. It's mostly just stored up, interacting directly with the metal of the antenna itself. This quote really hits the nail on the head. The near field is the prep space. It's the workshop where all the tools are out, things are getting assembled, and the final product, that perfect radio wave, is being built before it gets sent out. So instead of radiating away for good, the energy here just sloshes. It kind of moves out a little bit from the antenna and then gets sucked right back in over and over again. And that is why putting your hand nearby messes everything up. You're basically sticking your hand right into the middle of the workshop and disrupting the entire assembly line. And this right here shows why that effect is so incredibly local. The power in this workshop field just collapses with distance. It's super, super strong right up close, but take just a few steps back and poof, it's pretty much gone. It just vanishes. Okay, so what happens once the signal is finally built and leaves that messy workshop? Well, it enters the far field, and this is where the real journey begins. It's a much cleaner, more predictable place. The far field is where that signal is all packaged up and sent on its way. It's a true, self-sustaining electromagnetic wave that's now totally free from the antenna, just traveling out into the world. This is what we all think of as a radio signal. And unlike the messy workshop, the far field is incredibly organized. For a simple antenna like this one, the energy often radiates out in this perfect donut shape. It's this beautiful structured pattern that's designed for one thing: reliable, long-distance travel. And its power drops off in a completely different way, too. It fades out much, much more slowly than the near field. It's this gentle, predictable decline in power that lets a Wi-Fi signal reach across your house or a radio signal travel to the next town over. So let's just put it all together. You've got these two totally different worlds. In the near field, you have complex, stored energy that disappears really fast. That's the local workshop. Then you have the far field, with its predictable, radiated energy that can travel for miles. That's the global shipping network. Okay, so the obvious question is, where's the border? Where does that messy workshop end and the open road of the far field begin? Well, the thing is, there's no hard wall or set-in drop-off. You don't just cross an invisible line. It's more of a smooth, gradual fade, where that sloshing workshop energy dies down and the traveling, radiating energy takes over. And what's really interesting is that the size of these bubbles isn't fixed. It all depends on two main things: how big the antenna is physically and the wavelength of the signal it's sending out. So a giant AM radio tower is going to have a much bigger near field than the tiny little antenna inside your smartphone. Okay, this is all fascinating science for sure, but so what? Why does any of this actually matter in our daily lives? Well, it matters because clever engineers have figured out how to use the unique properties of each field for specific jobs. Just take a look at this. All that sloshing, stored energy in the near field, it's perfect for things that need to happen up close, like wireless charging for your phone or tapping your credit card to pay.
But for broadcasting information one way over long distances, that's a job for the far field. That's your Wi-Fi, your GPS, and your favorite radio station.
So you see, when an engineer designs a wireless device, they're not just sending out a generic signal. They're making a very specific choice. Are they building something to work in that interactive, short-range workshop? Or are they building it for the long-haul journey in the far field? It's a deliberate decision. So the next time you tap your phone to pay for coffee, or you're listening to a radio station from miles away, you'll know exactly what's going on. You'll know which invisible world you're using. And now that you can see these fields, what other wireless tech around you starts to make a little more sense? Thanks so much for joining me.